Good morning. I am Manjunath Desai. Let us discuss about the microprogrammed control unit. What is microprogram? A set of micro instructions is called as the microprogram. As we know, a set of instructions is called as a program. Similar to that, a set of micro instructions is called as a microprogram. For each instruction, there is a particular microprogram. Microprograms generate control signals for a particular micro operations. Let us know about the microprogrammed control unit. The main performance of microprogrammed control unit is it produces a control signals by a software using the micro instructions. So, as I said you before, a set of instructions is called as a program, and instructions requires a set of micro operations to be operated. A micro operations are performed using a control signals. Instead of generating these control signals by a hardware, that is a circuit design system which requires many wired connections that requires a lot of effort and time, we use these micro instructions that saves our time and energy. This means every instructions requires a set of micro instructions. This is called as the microprogram. As I said you, a set of micro instructions is called as a microprogram. These microprograms for all instructions are stored in a small memory that is called control memory. The control memory is present inside the processor. We can understand all these things using a flow chart, that is a program chart. The basic program chart goes like this. Program that needs a set of instructions. A set of instructions is called as a program. These instructions are operated using the micro operations, and these micro operations are performed using the control signals that is produced by a control memory. The control memory contains a micro programs in it, and that micro programs have their own micro instructions. As I said you, we can go here from bottom to top, that is a set of micro instructions is called as the microprogram, and these microprograms are placed in a control memory, and this control memory is responsible for producing the control signals, and the micro operations are performed using the control signals produced by this control memory. So each and every instructions are performed using the micro operations, and the set of instructions is known as the program. So this is about the microprogrammed control unit. Let us go for the Wilke's design for a microprogrammed control unit. Maurice Wilke, a scientist, he proposed the theory of microprogrammed control unit in the year 1952. This theory was just a concept till then because even the microprocessor was not invented while he proposed this theory. You may ask how it is. He just imagined if the microprocessor exists in the future, the program in it, the microprogram in it should be designed in this way to perform its function, and he proposed this theory. But basically this design looks like a circuit, but it is a software. We will understand how it is a software and not a circuit. We may have a look on this design. It basically looks like a circuit, right? But it is a software. We will go for the process, then we understand how it is a software and not a circuit. The process of Wilke's design goes like this. Consider an instruction that is fetched from the main memory into the instruction register IR, that is here the IR. Instruction fetched from the main memory to the IR, that is instruction register. From there the instruction is passed to the CMAR by using its own opcode. For a first address, the micro instruction uses its own opcode to process the address to CMAR. As I said, the processor uses its own opcode to identify the address for a first micro instruction. The address is located into CMAR, that is control memory address field, address register. Here, the address is located here using its own opcode. Then, the CMAR passes the address to the decoder. The job of decoder is it identifies the corresponding micro instruction from the control memory. The decoder identifies the corresponding micro instructions for address of it. See here, the lines we see, it looks like a wired connection, but basically it is a micro instruction. Each and every line we see here, it is the micro instructions, and the dots we see, it identifies the binary operation, that is, they are all the binary numbers. The dot we see is 1, and wherever the dot is absent, it is 0. We can see that we can read like this: the zeroth micro instruction, that is 1 0 0 1 0 0 1 1. We can also transfer it to the hexaform, that makes us easy to read. So this is not a circuit, but it is a software. As I said you, all these lines here are the micro instructions and not the wires, and hence it is a software and not a design, and not a circuit, sorry. The micro instructions has two fields in it, that is control field and an address field. Here we can see the control memory. The control memory that has the micro instructions, and it has two fields in it, that is a control field and the address field. It also has a multiplexer, that is status flag in it. Let us discuss one by one. Control field, it indicates the control signals to be generated. Here the control field that indicates the control signals to be generated, and the address field, it indicates the address of the next micro instructions. The address field present beside to the flag, it indicates the address of the next micro instructions to be generated. The address is further located into CMAR to fetch the next micro instructions. We can see the arrow marks here. The address field address the next micro instructions to the CMAR. The arrows we can see here from the address field to the CMAR. This address field is further loaded to the CMAR to fetch the next micro instruction. For a conditional micro instructions, there are two address fields. This is because the address to the next micro instructions depends upon the conditions. The conditions like true or false are decided by the appropriate control flag. As I said you about the flag, that is a multiplexer, this flag will give the value. This flag will give the value only when a control signal has been arrived to the specific location. It is basically a multiplexer which select one of it. That we can see there are two micro instructions, 1 and 2. There are two micro instructions. If the first instruction is true, then it will go to the address field. If it is false, it will go to the next line and takes it to the address field. So this is the performance of the status flag. The control memory is usually implemented using the flash ROM, as it is writable and not volatile. The advantages of Wilke's microprogrammed control unit is, the biggest advantage of it is the flexibility. That is, any change in the control unit can be performed using simply changing the micro instructions. It just requires a typing effort. But if we use a hardware circuits, it requires to be changing of wires, that requires a huge time, also the efforts. But here it requires a simple effort of typing. This makes modifications and upgradation of the control unit very easily. Moreover, the software can be much easily debugged as compared to the large hardware control unit. We can make many changes using this, but it is a bit difficult if we use the hardware system, the connections. Changing the wire is tough than changing the instructions, right? That is the main advantage of this. There are also the drawbacks. That is, the control memory has to be present inside the processing, which increases the size of the processor. That means the control memory that need to be present in the processor. This increases the size of the processor. This is also increases the cost of the processor. As we know, when the things increases, the cost also increases. So when the processor size increases, the cost of the processor also increases. The address field in every micro instructions adds more space to the control memory. This can be easily avoided by the proper micro instruction sequencing, but sometimes it is not possible to do the proper micro instruction sequencing, and hence it is also a drawback that the address field in every micro instructions add more space of the control memory. Let us now understand the Wilke's design using a process chart. As we saw, the instruction register, the first micro instruction is fetched from the memory to the IR, that is instruction register. Then the address of the first micro instruction is placed to the CMAR using its own opcode. The CMAR means, as I said, the control memory address register. Then the address will passes to the decoder, and the decoder identifies the corresponding micro instructions, and it will be placed to the control memory. The control memory has two parts, two fields in it. The micro instructions in the control memory has two fields, that is control field and the address field. It also has a status flag in it. We will see the control flag indicates the production of control signals using the micro instructions in it, and then they will be passed to the address field. But if the conditions in the conditional instruction is present, it is a multiplexer. The status flag, it is also a multiplexer which select one of the following. If the first micro instruction is true, it will take to the address field. If the first micro instruction is false, only if the first micro instruction is false, then it will go to the next micro instruction, and that will take us to the address field. The main function of address field is the address field take the address to the next micro instructions and places it to the CMAR, and hence the CMAR does its job. This cycle repeats until we get the micro operations that is used for the instruction to work, and that is instruction works. So this is the main theory of the Wilke's microprogrammed control unit. Hence, I think it is understandable. Thank you.